your domain always going to be for your exponential functions? Remember, your domain is what x values are you allowed to plug in.
So all positive?
So you can plug in positive values for x? If x is your exponent?
You can plug in any value for x.
You can plug in any value for x, right? Okay. If x is your exponent, that just means I'm going to raise the number to that power. Okay? You can raise that number to any power you want. So I can raise it to a power of 100, I can raise it to a power of negative 100, I can raise it to whatever power I want. So your power can be anything, you just raise it to that power.
Can it be decimals?
It can be decimals, right? You can raise something to a decimal power, that's possible.
Okay.
Okay? Anything can be your power. Okay? Your power can be whatever you want, you just use that caret symbol to raise it to that power. So that is always the domain of an exponential function, because if x is your power, the power can always be anything. There's never any restriction on what x can be. Okay, now how do I write that in interval notation?
It's going to be either all, well, it's negative infinity to positive infinity.
Negative infinity to positive infinity.
We have to go back to this, didn't we? Good old interval notation.
Now what about the range here? What's going on with our y values?
They're decreasing but not below 0, so it has to be 0 to positive infinity.
0 to positive infinity. That just means your y values are always positive. Okay, you raise the number to a power, you get a positive number. So your outputs are always positive. Okay, so my range there is 0 to positive infinity. Okay, but anytime, the range can actually be different because your function can be shifted up or down. Like your horizontal asymptote can be shifted down or it can be shifted up. But your domain is always going to be all real numbers.
When you type that in, do you put it like one side bracket, parentheses?
Those would all be parentheses.
Okay.
Now what was the question that I asked about domain number 5?
Number 5, yeah.
Number 5. Okay, 5 to the x plus 1. You guys can graph that. Okay, so we're going to put your power in parentheses. Okay, now what's going on with this one here? We kind of...
It has a horizontal.
The horizontal asymptote was at 1.
Is at 1, right? What that plus 1 does is it basically just shifts the function up by 1. So if you've got a number tacked on at the end, like plus something or minus something, it's going to just shift it up or down to that number. So normally I would have a horizontal asymptote at the x-axis. The plus 1 just shifts it up to positive 1. Okay? So my domain would still be all real numbers. My range would just be 1 to infinity instead of 0 to infinity.
Yeah.
Yeah, you didn't when you graphed it wrong. I'm confused.
She's right, your graphs are wrong. You
Your
go back to your
graphs are
graph.
wrong. You put the
Oh,
plus
I
one
read
at
it
the end.
wrong. I read it wrong, yeah. It's 5 to the x plus 1 is in the power, yeah. You guys need to say something before I go into it.
So can you after you regraph it, can you restate what you just said?
Well, it'll look different then.
Well,
So
that's
the horizontal asymptote is no longer at 1.
No. It's only when you've got a number added or subtracted outside the parentheses, or outside the power, that it would shift up or down. Okay? This one is just going to look the same as 5 to the x power. It's still going to have an asymptote at 0. Okay, what's my domain? My domain is always negative infinity to positive infinity. Because I can plug in any power there. Okay, what would my range be?
0 to positive infinity.
Okay, 0 to positive infinity. It looks like I've got an asymptote at the x-axis, and then my function goes up to positive infinity. And then the horizontal asymptote would be y equals 0. Now here's one that that's like the one I was trying to just do. This is one where you've got the -3 outside the power. Okay? So that -3 here is actually just going to shift that down, the graph down to -3. Okay, so I think A would be my graph here. So when you've got a number added or subtracted at the end outside your power, it's going to shift it up or down.
So when you do that, you only put the x in parentheses?
Yeah, I would only put the x in my power and then just put the -3 outside the power. Okay, so shift your asymptote down to -3. Okay, my domain, again, your domain is always negative infinity to positive infinity. Never anything different for an exponential function. My range, well, if I'm shifting my asymptote down to -3, then my range would be -3 to infinity. Okay, and my horizontal asymptote is at -3. Now, I think the bulk of these questions are actually application questions. Here's one with the E in it. Let's look at number 10. Now we can actually figure out what graph this should be just by process of elimination here. Which one can we eliminate right away?
This first.
A. Okay, the line, it shouldn't be a line, it should look like an exponential function. Now between B and C, what is the difference between B and C?
Positive and negative.
Growth and
Okay, B is growth and C is decay. Now E to the X, what kind of number is E?
positive.
It's like 2.7 something, right? So that's a positive number. So should that be a growth function or a decay function?
Growth.
It should be growth. You're multiplying by a positive number that's greater than 1. Okay, if you keep multiplying by 2.7 over and over again, your numbers are going to get bigger. So I should choose the growth function, which is B. Okay, now f of 1, f of negative 1, f of 2, what are they asking me to do there?
Plug those two in the exponent.
They're asking you to plug those into the exponent. Plug those in for x. Okay, so they're asking me to take e to the x and plug in 1. So I want to use my e to the x button on my calculator. So I want to hit second ln, and then just give 1 as my power. Round to 3 places, so that'd be 2.718.
So why wouldn't you just type in E there? Because isn't that E?
You can't just type in E. If you hit e to the x, it automatically gives you the caret symbol, so you have to put in a power.
Oh, okay. No, I mean as the answer here.
Oh, they want it.
Do they want you to realize
they want
that
the actual
that
number.
is?
Yeah, they want the actual value. Okay, then they want me to plug in negative 1, so I want to do e to the negative 1 power. Okay, so that's 0.3678. That would round to 0.368. Okay, and then they want me to plug in 2. So e to the positive 2 power. 7.389. Now what's my horizontal asymptote of my graph? The x-axis, which is y equals 0. Okay, because on my graph it's going down to the x-axis but not crossing it. And what about my y-intercept?
0 to infinity.
Y-intercept is 0 to infinity?
Oh, the y-intercept.
Doesn't make sense.
Duh.
0, 1.
Do you guys remember how to find the x-intercept?
You can look at the
Or the
graph.
y-intercept, sorry. You can look at the graph?
Or set x0.
You set x equal to 0. Remember, to find the intercepts, you set the opposite variable equal to 0. So to find the y-intercept, I would have plugged in x equals 0. So for the y-intercept, I would have e to the 0 power. Anything to the 0 power is 1. Check it if you don't believe me. E to the 0 is 1. So when x equals 0, y equals 1. That is my y-intercept. Okay, so don't be intimidated by those E problems. You can treat it just like any other number. Just use the E button in your calculator.
Mine's a -3, but when I put it in, it tells me the answer's not correct. What I do
You
wrong?
got to round it to 3 places. So 0.0497 would round to 050.
Oh, okay.
Because that 8 after it would round that up to, or that 7 after it would round the 9 up to 0 and the 4 up to 5. Now a lot of these are word problems. Where do we get to the word? A lot of these are just plain old graphing problems, which you guys can do.
Number 17 is one.
Okay. Okay. A lot of these are word problems because you see a lot of applications of exponential functions. Like population growth is an exponential function. If you guys take accounting, all of accounting 2 is about exponential depreciation. 5%, if you're losing 5% of your value. And here's a example of exponential decay, where you're losing value from your advertising. So if you think about advertising, at the end of an advertising campaign is when you would have the most recognition of your product, because you've just done a campaign, everybody's seen it, it's fresh in people's minds. But then after you end your campaign, it just sort of fades away. It kind of fades out of people's memory, and they start to forget about things. Okay, so this says at the end of an advertising campaign, weekly sales decline according to the equation y equals 18,000, parentheses 5 to the negative 0.08 x. Okay, now let's kind of examine this here for a second. Okay, what is the base of my function, Mary?
18,000.
The base is not 18,000.
5.
The base is?
It's 5 to the negative 0.
5 to the negative 0.08 x. Okay, now what is 5 to the negative 0.08 power? And I think I just closed my homework. Okay. Questions about this?
15.
Oh, now you have a new problem.
I screenshotted this one, so I'll just continue.
Oh, okay.
I'll just continue with this one. Actually, no, I need to, no, because might as well answer this question. Let's try this again.
It happens.
I just changed my 18,000 to 16,000. So my base is 5 to the negative 0.08, which is 0.879. We'll call that 0.88.
Would that be accurate enough to actually answer my math lab?
No.
Okay. You would want to keep the entire decimal.
I'm just calling it that for it. You'd actually need to use the 5 to the negative 0.8 in your calculator. I'm just trying to, because 5 to the negative 0.8 doesn't really make sense to me, but 0.88 makes sense to me. I know what that is. Now, what does 0.88 mean in terms of losing your advertising?
You're losing 22% a week.
You're losing 12%. Okay, so if you every week you're multiplying your sales by 0.88.
I'm sorry.
Okay, that's okay. It's Fake Monday. Yes.
Hey, can you show us how that's supposed to be plugged in here on the graph?
Yeah, in a second.
Okay.
In a second. Every week you're multiplying by 0.88. So every week you're losing 12%, and you have 88% of what you started with. Okay, so every week your sales are decreasing by about 12%. Not exactly 12%, but approximately 12%. So if you're keeping 88%, then you're losing 12%.
Well, that's compound 12%. You're losing 12% of the previous percentage.
Yes. So it's going down, and it's also going down by a larger, or by a
smaller and smaller and smaller.
It'd be going down by a smaller amount. Yes. So you lose the most during the first week, and then a smaller amount after that. I'm getting a little too. It's good to think about those things. I like thinking about this stuff. I mean, otherwise, why do we care about this? If we're not going to think about how it actually works in the real world, then why bother? Okay, now what are the actual answers to my questions here? At the start of my campaign, what are my sales?
16,000.
16,000. That's what that number stuck out in front represents. That's your sometimes it's called the initial value. Even if you plugged in x equals 0, that's what you would get. So my sales start at 16,000. Now after 4 weeks.
So you're gonna lose 4 compound interests of 12%, basically.
Mhm. Now I can put this in the calculator as 16,000 parentheses 5 raised to the, remember, put your power in parentheses, that's where people go wrong. Negative .08, negative .08, not just .08, times, if it's been 4 weeks, I would multiply by 4.
So round to the nearest cents as possible, so 95,000 or 9,559 and 82 cents.
95.59.82. Now Ashley asked me how to graph this because she wants to use the table, I presume.
If it involves math, I prefer to just use the
Okay, so
table.
put in your 16,000 first. And then instead of using parentheses for that first multiplication, let's use the star symbol. It likes that better.
That's weird.
Yeah, I know. It should understand both, but it doesn't. Okay, and then 5 caret parentheses, and then in parentheses negative .08 x.
Wait, now will you put that in the notes too?
Yes. Now why am I not seeing anything?
Because it's at 16,000 right now.
Because it's at 16,000. Look at your table value. I need to adjust my window. I just can't see it.
It should be going down from 16,000, so
It should start at 16,000. Now everything below 0 we can ignore because that doesn't make sense.
negative 1 week of your advertising.
Negative 1 week doesn't make sense, yeah. So we start at 16,000 and then we go down from there. At 4 weeks I'm at 9959.82, which we said.
The peasants proof. I'm doing better now.
Now if you want to see the graph, I just need to make my y values go up to 16,000 because 16,000 is where my y value would be at the highest. So if I just make my y max up to 16,000, then I can see the graph. Okay? So it looks like after 10 weeks, I've gotten to about 5,000, and then it would just go on from there. It would approach 0. It wouldn't actually hit 0. Now, why could it not actually hit 0?
Because you're taking a positive number to an exponent.
Okay? I'm taking 88% of my sales. Okay? 88% of something is still something. Okay? No matter how small it would be. Okay,
It's 82.
82, not 52. Okay, does the sales eventually reach 0?
No.
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 Yeah.
No. Something raised to a power is still something.
Is
Can't
this
be 0. Yes.
as an exponential function, then when we're raising it to this variable, does the calculation take your base amount of 16 and reduce it by 12%? Take that amount, reduce it by 12%,
Yes.
that amount, reduce it by 12%?
The function does all the steps for you.
That's what I was
So you
meaning.
don't have to do it in steps. The function does that.
So it's not just 3 times 12% of the base, it's
No.
okay.
It'd be times, like, if I raise it to the 5th power, then that'd be like, the function will roll that in and multiply by the number 5
So
times.
this is reverse compounding.
Yeah, that's what I was meaning by compounding,
Yeah.
increasing.
Yeah, compounding is a good example. Compounding goes up, the depreciation just goes
That's
down.
okay. Okay, wait, let's explain it here.
Well, somebody just mentioned compound interest, so let's talk about compound interest, which is number 16. What do you guys know about compound interest?
I know
Kim
nothing.
left, so she was the one that was talking. So if you make 2% on an investment every quarter, okay, then every quarter they would calculate 2% of your value and then add that to your account. Okay, and then the next quarter you get 2% again every quarter. But then the amount that you're calculating based on would actually go up. So your amount of interest is going to go up because you've got your previous interest earning interest.
What does that term, what compounded, what does that mean?
Compounded just means they calculate it and add it to your account so it becomes part of your balance.
Okay.
Okay, so the formula here, there's a couple different formulas. If your interest is compounded annually, which means they just calculate interest once a year and add it to your account. Your A, which is, do they call it A in here or is it S? S. Alright, I'm used to calling it A, so we call it that. Doesn't really matter. P times 1 plus R to the T power. P is your principal, that's your starting amount. So how much you initially put in the amount in the account. And I believe it's principal P-A-L, not P-L-E. Doesn't really matter. It matters to me.
Me too.
Okay. R is your interest rate.
And why is it +1?
The +1 lets you keep what you started with, and the R makes it grow.
Ah, okay.
Okay, because if you only had the R, then you would only earn that you'd only have that
P
percentage.
times 1, I get it.
The one keeps what you started with.
Yeah.
There's a 1 there, 1
Yes,
plus
1 plus
R?
R. The one keeps your original balance, and the R is the amount that you grow.
Okay.
Okay. R is the interest rate. If they give you a percent as the interest rate, we need to change that to a decimal. So instead of 5%, you need 0.05. You guys know how to change 2% to a decimal, I know. Divide by 100 if you can. Okay, and what is T? T, since we're compounding annually means once a year. So T would be the number of years.